Hi, my name is Chris Beasley and I'm a senior curriculum developer at MuleSoft. This Friends of Max video will be a quick course on Anypoint DataGraph and how it can be used to accelerate development. At the end of this course, you should be able to summarize the development challenges in enterprises with growing number of APIs, explain why DataGraph is useful for accelerating development of applications requiring data from multiple APIs, create a unified schema and DataGraph API using existing APIs, and query a DataGraph API. First, let's start with a quick introduction of DataGraph. As a MuleSoft customer, following the API-led connectivity approach to integration, your IT has created numerous system APIs to unlock data and functionality in large numbers of systems present in most enterprises today. Business level IT has then created process APIs to perform business logic and expose the functionality unlocked by those system APIs to the rest of the enterprise. Application teams are now getting started creating experience layer APIs to use those process APIs. Using the experience layer, those applications can craft unique experiences needed by their specific applications. As you can see though, challenges are beginning to occur at the application level, which making it difficult to scale development there. Data needed for those front-end applications is fragmented across multiple APIs. In an application as needing product information, for example, most of the product info is going to be found in the product info API. Some of the info needed may be in the order management API, and even more info in the inventory API. Collecting data from all these REST APIs requires a developer to make multiple requests, and since we're talking REST APIs, those requests are generally done one at a time. Then the response from each API has to be processed in custom code where only data needed for the application is used and all other data is ignored. This cycle's then repeated inside that application for other data, let's say customer data. Some of your customer data may be in a customer API while other parts of the data is in an account API. This cycle's repeated for that customer information. Then each application itself is repeating the same cycle, as likely the other front-end applications are using pretty much the same data sets. This is where GraphQL comes in. GraphQL is a query language used to query multiple APIs. GraphQL uses a unified schema to filter and transform those multiple API responses into a single response format specified in the request. What this means is the developer writes the request to the GraphQL API, and in that request they specify the fields that they would like to see from the entire unified schema, not necessarily the entire schema, and the response from the GraphQL API will contain just those fields. The unified schema allows consumers to request data from any fields that exist within any of the APIs associated with the unified schema. What this means is actions that would have normally required numerous API requests can now be done in a single request because GraphQL is managing those multiple invocations and also creating or graphing data together in a response. Now our experience later with GraphQL can look like this. As you can see, we're still reusing our core system and process APIs, but now we have one single GraphQL API that each front-end application is using, and each front-end application is making distinct requests to the GraphQL API to get just the data they need for their specific application. DataGraph, available in the MuleSoft Anypoint platform, allows architects to build these graph-enabled APIs. It is a user interface that allows you to build a unified schema using your existing APIs, It'll guide you through creating a query of that unified schema to get the fields required and filtered for your application or applications, and using the power of Anypoint platform to manage those graph-enabled APIs. Using DataGraph, we can build a unified schema. The interface allows you to build this schema by looking at all your underlying REST APIs. You can connect all those together with metadata that graphs each individual API schema together into one. Using the example below, see how we're collecting some product information into a unified schema. Some of that product information is coming from Order Management API, product name and unit price. Some is coming from the Product Info API, SKU description and image URL. And then we have a repeating set of information coming from Product Inventory API. As we're constructing our unified schema, we can rename fields that meet our needs or the needs that we want to convey, like naming conventions. We can also merge data. Merge data allows you to take data from two or more APIs and join them together using common identifiers. That way you can represent data from two or more APIs at the same level in your schema. Again, using the example, product name, unit price, SKU description, image URL are top level data fields in our schema. Next, we can link data, again using common identifiers, to bring in sets of data. So in our case, products can have inventory in multiple warehouses. So by having the product inventory object inside of our schema, this allows us to have a list of product availability in multiple warehouses. Once we've built our schema, DataGraph allows you to build queries on that schema, and it assists you with IntelliSense to know how to construct the queries and then run the queries to see the results. As you can see below, our schema exposed a method called ordered products with reserve by ID. We can specify a product ID, and by doing so, all the underlying APIs will be evoked. Again, for our case, we have order management, product, and inventory, and the responses will be filtered to just the product ID we've specified here, 332. In the response, though, all we want to see are product name, SKU unit price, and then for inventory, we're really only interested in the reserve quantity at each warehouse. This query, built in DataGraph, can then be taken to an application and implemented as a REST call. When the application invokes our GraphQL-enabled API in DataGraph, this is the response that application will receive. We can also manage our DataGraph APIs in the Anypoint platform. When we're building and constructing our unified schema, we can use a trace feature to find bottlenecks in performance when invoking the underlying APIs. You can also view logs that will assist with troubleshooting. We can assign a custom URL to our DataGraph API, and this will be the URL we give to our front-end developers. Also, you can control access to API using authentication methods provided by Anypoint platform. These include basic auth, client ID secret pairs via headers or query parameters, pass-through authentication, OAuth 2.0, and mutual authentication. Authentication can both be used at the front end to control access to the DataGraph API, but also as you're bringing in your underlying APIs, you can configure these authentication methods that were implemented in those underlying APIs. Now let's go into a walkthrough where we'll create a unified schema in a DataGraph API. Before we start with the walkthrough, there are a few prerequisites. First, you'll need to access the Anypoint platform at anypoint.mulesoft.com and create a free trial account. It's recommended that you use a free trial account for this walkthrough instead of one of your existing accounts. Next, provided with this course, there should be a link to some student files. The name of this file is datagraph_studentfiles.zip. Please download this file to your local machine and take note of where you've saved it, and we'll use it later in the walkthrough. Also, after downloading the zip, go ahead and unzip it, and you'll find it contains two files. One is the spec for the training APIs that we'll be using. This is a RAML spec. The name of this file is datagraph-training-apis-1.0.1-raml.zip. Also, there is a datagraph_queries.txt files, which contains the queries you'll see me use during the walkthrough. Finally, provided with this course, there should be a URL to some DataGraph training APIs. This URL points to an implementation of the APIs we'll use in the walkthrough to build a unified schema and create DataGraph queries. The scenario for our walkthrough is this. AcmeCo has developed APIs to expose data and functionality from their core systems. The process APIs include order, shipment, customer, and product. Keela, the integration architect for application development, has received numerous access requests to process APIs from the development teams. She knows the relationships of data between the APIs will require each development team to duplicate the work needed to invoke the APIs multiple times to get data needed for their applications. She wants to use DataGraph to build one API for the development teams to use to quickly create their application-specific experiences. Here is the architecture for our walkthrough at AcmeCo. As you can see, at the process layer, we have product, order, customers, and shipment APIs. The applications being developed are for a web app, mobile, and in-store checkout. All these applications need data from the underlying APIs. We're going to use Anypoint DataGraph and a unified schema to produce one API that each application can use. To get started with our walkthrough, we need to import a specification for the APIs we will use in DataGraph. This will allow us to mimic the APIs that are in place at AcmeCo. As you can see, I am already in the Anypoint platform at anypoint.mulesoft.com, and I'm signed in with a trial account that I created earlier. To import the specification, let's go to the Exchange. Even though we have to have a specification in Exchange, it does not mean that we have to use MuleSoft-only APIs. You can use any external API, but you will have to create a specification either in OAS or RAML to import into your Exchange. Let's click Publish New Asset. I'm going to name this asset DataGraph Training APIs. The type is going to be a REST API. I'm going to upload a RAML. First, let's choose a file. Now this is a file that was provided with the course. As you can see, it is in my downloads folder. It is called datagraph-training-apis-1.0.1-raml-zip. I'm going to select that and open. The rest of the options are defaulted, and you can save those as is and click Publish. Now that we've imported our specification, we can examine it. As we saw in the architecture overview at AcmeCo, there's a Customers API, a Products API, an Orders API, and Shipment API. These APIs all have various GET methods for getting information from the various APIs. We also need to add an API instance URL to our Exchange. This way, DataGraph will know where the implementation of this API is. There is an implementation of these APIs hosted at MuleSoft. So all you'll need to do is locate the URL that was provided with the course and copy it. Then click Add New Instance, name it. I will name mine DataGraph Training APIs. Then I will paste in the URL that was provided with the course. Once that's done, I will click this check mark, and now we have an API instance that DataGraph can read. Now let's go to DataGraph. To access DataGraph, we go back to our main menu and click DataGraph. Now we're ready to add our APIs. Click Add API. As you can see, DataGraph went and looked in our Exchange and saw that we have an API there called Training Graph APIs. If you had other APIs in your Exchange, they would all be displayed here. Let's now select our DataGraph training APIs and click Next, Configure URL. Now we need to confirm the version of the asset from the Exchange. For us, we had a V1 of our asset, so we're ready to confirm selection. Now we need to confirm the URL. When we imported the spec for this API into Exchange, we configured an API instance with a URL to where our API is. DataGraph has read that URL from the Exchange, and we can use it here. If there's another API instance that's not set up in Exchange, you can simply click Add New URL and then enter that URL manually. We're going to stick with what's in Exchange. Now we're ready to configure security. So click Next, Configure Security. As you can see here, there are several authentication methods you can use to secure your DataGraph endpoint. Basic auth, client ID, custom headers, pass-through using MTLS, and OAuth 2.0 are all supported. For the purpose of this walkthrough though, we're just going to keep it simple and use no auth. Let's click Preview the Schema. Now the DataGraph tool is showing us the schema of all those underlying APIs. As you can see, we can view customer and see that it contains address, which is also a type called address. We can click on and see that. Now I'm going to go back to the schema. We can see order, product, and shipment. So DataGraph has pulled in, using the metadata from Exchange, it has pulled in the schema from those underlying APIs. Now let's start building our schema. Click Next, Edit Schema. The first thing we'll want to do is enable collaboration. This allows the underlying schema to be present in our unified schema. Let's start with customer. So I've clicked on the level 1 type customer, and then I'm going to click Enable Collaboration. DataGraph has analyzed the API and saw that there's one GET method. We need to select our default query method for this type, and in this case there's only one, so we're going to select Customers by Customer ID and click Next. Then we need to tell DataGraph what is the unique identifier of this schema for this API. In this case, it's Customer ID. Then we're going to click Confirm. Now we need to do this for the rest of our APIs as well, because we want to add them all to our unified schema. So let's click Order, Enable Collaboration, Default Method Orders by Order ID, and Order ID is the primary key. Same for Product, Enable Products by Product ID, Product ID. And Shipment. Enable Collaboration, Shipment by Order ID, and for this API the primary key is the Order ID. So I will select that and then click Confirm. Now that we've enabled collaboration, we can now fine-tune this schema so that it has naming conventions more in line with what we want to use. Let's go back to Order. As you can see, we have a field called Status, and its type is enum type 0. Let's change that to something that's a little more relevant. So click on enum type 0. Now, DataGraph is telling you that this field is hidden. What this means is when the unified schema returns values, order status, or this status, enum type 0 is what is named now, will not be visible. So let's go ahead and enable that so that it is visible, and rename it so that it makes a little more sense. We'll call it order status. Okay, I can navigate back to the API schema using this breadcrumb navigation located here. So I'm going to click API schema, then go back to order. Now, as we'll see later, we'll have both an order status and a shipment status. So let's go ahead and rename this status field so that it makes a little more sense in context. So I will change what's now called status from the underlying order API, and for my unified schema is now going to be called order status. Now let's do the same for product. On product, we have enum type 1, which is the type for category. Let's click this enum type 1 and give it a name that's a little more product oriented. Again, DataGraph is telling you that this is currently hidden, so let's check this control here to make it visible, and we'll rename it to product category. As you can see there, as I was renaming, DataGraph gives you hints that certain names are not valid. So let me take that space out. We'll confirm that change. Then I'm going to go back to my API schema, again using my breadcrumb navigation. I'm going to go to shipment, and it has enum type 2 here. So again, I'm going to click on it. Again, I'm going to change it to hidden, from hidden to visible, and then rename its type to shipment status. Confirm. Now let's go back to our shipment schema. And again, since we have status and order and status and shipment, we can rename this to something that's a little more relevant to shipment status itself. So again, status is the name of this field in the underlying shipment API, but in our unified schema, we can rename it to shipment status. Now let's join or link some of our schemas together. Let's start with order. By default, DataGraph has automatically added one blank link section for us to configure. Our first link is going to be to customer. So click the drop down and then choose customer. Now DataGraph is saying what is the common identifier between customer ID, and order. So for us, it will be customer ID that exists on orders. Now each time you configure a link, you'll want to be sure to click Save Changes before you go forward. Okay, now let's add a link to shipment as well. So let's click Add New Link. We want to link orders to shipment. So I'm going to choose shipment. And inside of the order, our order ID is our primary key for order. And when we configured the shipment API in our unified schema, order ID was also the primary key in shipment. And again, I've added a link, so I want to do Save Changes. Now I can collapse this box and you'll see that we have two links from order to shipment via order ID and order to customer via customer ID. Now we're ready to add this to our unified schema. At this point, our unified schema is being generated, and as you can see, there's a note here that says this may take up to 15 minutes. We can go ahead and proceed to the unified schema, and as you can see, our schema is being updated. After 15 minutes or so, this will change to up to date. Now we can review our schema. As you can see here, all the methods that were read from the schema are present and we can view them. The ones that we marked as default when we enabled collaboration have a default method selected, and there's other methods that were available from the underlying APIs. We can also examine some of our types. So if we look in order, if you remember, we changed status to order status for our unified schema, and we changed the type to order status. We also did the same in shipment, where we now have shipment status named as a type shipment status. Now let's build a GraphQL query of our unified schema. To do so, click Run Operation. By default, a client ID policy is applied to all GraphQL APIs. This can be changed in the API Manager. For this course, though, we're going to leave it in place. The client ID and secret pairs are stored in the form of an application. If we already had an application configured, we could select it from this box by using the option Use one of my existing applications. Since we do not, I'm going to select Create a new application and use it immediately. Now we need to give a description of our application. I'm going to call this the AcmeCo mobile app. We can add a description if we have it. The application URL can be where our application is running from, and if we're using OAuth 2.0 for authentication, we can enter the callback URL now in this box. So I'm going to create and request access. Now that we have our access in place, let's start writing a query. Let's start by looking at the customers in our schema. I can simply start typing customers, and as you can see, type ahead is telling me there's a type or a method called customers. I can simply hit tab and autocomplete. Now I know that this is a method, so I need to open another set of curly braces. Now I can start choosing fields from the customers part of my schema. I know that there's a customer ID, a name, and an email. So as you can see, the DataGraph tool is helping us construct our GraphQL query. Now when we're ready, we can click Run. And what DataGraph did was it initiated the backend APIs, only the customer API, and it went to get those fields and return them. Now we can also see that DataGraph is using the query that we perform. If we remove email, we'll see that our new response does not contain email. The backend customer API did return email to DataGraph, but using GraphQL, we filtered that response to only just what we needed. To show the backend invocations, you can use trace. So click the sub-menu box here and choose trace query. Now what will happen when we run our query again, we will see what DataGraph did on our behalf. As you can see, we reached out to the customer's API and we got our response back. We can add an email again, and now with trace enabled, we will see that response as well. So as you can see, now we're getting customer ID, name, and email from our customers. Let's look at orders. So I'm going to remove the customers part of my query, and we'll use orders. On orders, we have a field called order ID and order status. When I run this query, you can see again, DataGraph on our behalf reached out to the orders API, got the order information for all orders. In our sample data, we only have one order, and it brought those back and filtered just the fields that we requested, order ID and order status. Now let's look at a query that will use all the underlying APIs. First, let's go to the student files directory from the zip that we downloaded in the prerequisites, and let's open up the DataGraph queries.txt file. You'll see the two queries that we did earlier, they're here for your reference, but let's go ahead and copy this bottom query, and we'll take that over to DataGraph. This query uses the orders by order ID method. As you can see, we're specifying a specific order ID that we would like to see the data for. If we look at the query further, we're still getting order ID and order status, but now we want to see the customer information, the item or product information, and the shipment information. When we run the query now, our response is still in JSON format. As you can see in trace, you can see it reached to orders, it reached to customers. Since this order had two items, it had to hit the item API for us twice, and then shipment. So as you can see, DataGraph is making those multiple invocations on our behalf with one request. With our query written, let's look at what a developer would need from us in order to use this query in our endpoint. First of all, we're going to need the client ID and secret that we're using. You can see this by going to the sub-menu and clicking View Current Credentials. I'm going to capture the client ID and secret, which the developer will need in order to use our endpoint. Next, we need the URL for our DataGraph API. We can get this by clicking Unified Schema and choosing Overview. The API URL is here. By simply clicking on it, you can see that URL has been copied to our clipboard. Now we can mimic the behavior of the application by using a REST client like Postman. With the URL to our API on my clipboard, I will paste that URL here into a GET request. I will go to headers, and I need to add a client ID and a client secret as header parameters. The client ID, which I captured earlier, I will paste here, and the secret I will paste here. Now we need to add the body to our request. Let's click body, and Postman has a GraphQL body type. I'm going to paste in the query that we created earlier, and now we're ready to run. So as you can see, our response is a JSON response, the same response that we got in DataGraph. The application developer can now take this body and the client ID secret credentials and put it into their application and start using our Graph API. In summary, growing numbers of APIs can introduce repetitive work by multiple application development teams. DataGraph uses GraphQL to remove the repetitive work of multiple API invocations and processing by providing a single API that all application teams can use to get unique data sets needed for their applications. The DataGraph tool is used to create a unified schema, which is a representation of all the data in your underlying APIs. The tool assists you with merging and linking that data into your unified schema and allows you to change field names to match your naming convention. Once you have your unified schema, DataGraph can assist you with creating queries with features such as IntelliSense to help you craft the query needed by a specific application. Once this query is created, it can be handed to an application team to put into their application and accelerate their development. Thank you for watching this Friends of Max video. Hopefully this course has been useful for you and you can start accelerating your own development using Anypoint DataGraph. Please watch other Friends of Max videos located on this channel. Also, go to training.mulesoft.com to see training opportunities available. Thank you.